everybody. I'm Sari Custer, and this is Sari on Science for Arizona Science Center, bringing you today's 1 p.m. live demonstration. I know many of you are just joining us, so we'll get going here in just a moment. And while everybody's joining us, I want to say thank you to all of you who are at home doing your safe social or physical distancing, trying to keep our community safe by keeping us separate. We want to remember to keep at least 6 feet between ourselves and other people at all times to help limit the spread of disease. So thank you again for staying home and doing that. But just because you're at home doesn't mean the science has to stop. We've got our activities every day, so 9:30 a.m. for our early learners on Facebook and 1 p.m. for everybody. Everybody can join all of them anyway, but that's what's happening on Facebook Live. And of course, we've got our website where you can find all kinds of resources for science at home at azscience.org. All right, so I know all of you are here because this demo is hot. Yes, I said it. I did. We are doing combustion today. Have you all ever heard of combustion? Some of you have, some of you haven't, but don't worry. It's a fancy word basically for fire. So we're gonna look at how you make fire or combustion happen today. And before we get going, I need all of you to look at your adult or look at yourselves and raise your right hand. All right, now repeat after me. I promise to never, ever, 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 ever play with fire. You're gonna leave it up to the professionals. We here at Arizona Science Center are being super safe. We've got our PPE, we've got our fire extinguishers. We don't want you to try this one at home. Leave it up to the experts. But let's continue talking about combustion. So this is a piece of our demonstration, Great Balls of Fire, where we talk about combustion. What does it take to make combustion happen? There are 3 ingredients. You guys wanna type in the comments if you're at home, what does it take to make fire happen? And we've got Josh manning the camera there, so he's gonna read off if we've got any responses, which we might not have yet, but that's okay. So our first one that we need is oxygen. All right, everybody take a big deep breath. And breathe out. All right, so we need that air all around us. And in the air, we need the oxygen, and the fire also is gonna need that oxygen too. So the second thing we need is heat. Now everybody put your hands together. Rub. What do you feel? All right, so when you rub your hands together, your hands drag back and forth, your skin drags back and forth to create some heat. Heat is what we need there. So we need heat to make fire happen. You might also be thinking of, say, a campfire where we've got just fire or a lighter, a spark, something like that does also help here for the heat component. So we've got oxygen, we've got heat, and now the last thing we need.
Jess says heat, fuel, and oxygen.
Oh, Jess says heat, fuel, and oxygen. So you got the last one. Nice job. We need fuel. So again, going back to putting our thinking caps on, imagining a campfire, we start with the wood. So the wood in a campfire is the fuel. So anything that burns, if you've ever burned a piece of wood, or if you've seen cotton burn, or if you've ever even used a grill, so propane on a propane grill, or the coal, or say even just in a lighter like this, the butane, right? That is the fuel. So let's see, should we try and make combustion happen right here? I think so too. Otherwise, we wouldn't say this demonstration is hot. We gotta make it happen. All right, so as you can see, I have a candle right here. I'm gonna go ahead and light this. What is this going to be as part of our combustion triangle? What part? All right, if you guessed it, that is our heat. We're gonna use this tube to collect our next piece. So we're gonna scoop up some air. We're gonna get that oxygen. If you're at home, you can blow, make that happen for me. Move the air all around. Great job. All right, we got a little extra oxygen now in our tube. All right, so we've got heat, we've got oxygen. What's the last thing we're gonna need to make combustion happen? Fuel, you nailed it. All right, so we're gonna make this happen. And you know what? I'm gonna even turn off the lights, so bear with us here so that you can see a little bit better when we do make this happen. We're using a fuel called lycopodium. This is actually a plant spore, and well, you'll see what happens when we aerosol it. And let's do a countdown, everybody. You ready? 3, 2, 1, combustion. Woo! All right, that was pretty cool, right? We made combustion happen right there. All right, so I'm gonna turn these lights on so you can see me again. That was awesome. Now, I noticed that our heat is still on, but let's see what happens if we can smother it. What happens if we take that away? All right. Oh, and why am I putting the beaker over top? What do you guys think? And you know, there's a little lip down here, so it might be actually getting some in. I'm taking away the oxygen, and you can see the fire in the candle goes right out once we take away all that oxygen. So we can try it again with our same setup here. We've taken away our heat source now. We're gonna, let's do it again. Let's add our oxygen from the air. All right, here we go. We've got oxygen. And let's add our fuel again just to see if anything happens. All right, 3, 2, 1. Nothing, right? Because we need what? All three ingredients. We need heat, fuel, and oxygen all together to make combustion happen. All right, so that's one more thing I want to teach you guys today and why that's super important. When we talk about fire safety, how many of you have ever heard stop, drop, and roll? A couple of you? All right, so if you are ever in a situation where your clothing catches on fire, I know that's really unfortunate. We really hope that's never ever the case, but you may have heard stop, drop, and roll. So what you want to do is stop what you're doing, drop to the floor, and start to roll. Now when you do this rolling, you're taking those flames and you're removing the oxygen. You're smothering those flames, removing the oxygen from the situation. So that removes one piece of that, what we call the combustion triangle, so one of those three pieces, and no more fire. All right, so I know you guys are here for the hot demo, so should we see it at least one more time? All right, let's see one more of these. I'm gonna go ahead and light this. Matter of fact, we're gonna light another piece for us. I've got a sponge here that works really well as a heat source, and I'm gonna add a little fuel onto our sponge just so that it'll keep it burning. It tends to be a longer lasting style of a candle, so I'm gonna light that here. Woohoo! All right. Pretty big flame there, so there's our heat source. We're gonna scoop up some more oxygen right here with our air. All right, put it right over top. All right, I'll turn off the lights for you all to see. Here we go. And I need a really big countdown from you guys at home. So here we go, 3, well, let me get a little bit more. We'll make this one really good. All right, here we go, 3, 2, 1, combustion. Woo! All right, and our heat source is going. I'm gonna show you guys something really cool too. I don't know if you can see me or not, but here's hoping you can. We're gonna add something a little special to this particular one, to our fuel. So I'm gonna use lycopodium again for our finale, but I'm also gonna add a little chemical called calcium chloride. And
Sari,
calcium chloride.
Ryan asks, what makes fuel more combustible than other materials?
So any material that's combustible would technically be a fuel. So great question. All right. So here we go. We are using our flammable lycopodium, and we are adding a sprinkle of, you know what, I'm gonna turn this on really quickly before we go because it's really worth seeing. I'll turn on a light. Josh, can you get in there? Can you guys see that powder? What color is it? Tell me in the comments. I'm hoping you see it as green. It is a green powder. So again, this is copper chloride. Did I say calcium before? I might have said calcium, but it is copper chloride. Hoping I got my words right. Okay, so we are all prepped for one more. We've got our heat source. We've got our oxygen. Let's just make sure we've got lots of oxygen, but we know we have it because, well, our flame's still going. But let's get a little more just in case. All right, a little more oxygen. Here we go, over top of our flame. Let's see what happens. Lycopodium and copper chloride, 3, 2, 1. Woo! Did you guys see that? And can you see the color of this flame? Let's see if you can see it. All right, it's no longer orange anymore, which is that color of carbon burning. It happens to be a blue-green color, which is the color copper burn. So when you are looking at fireworks next, you can remember that when we add certain elements to flame, they do burn a particular color. And of course, none of this would happen without that combustion triangle. We need those three things. We need oxygen, we need fuel, and we need heat, and we saw it happen right here. All right, if you have any other questions, by all means, put them in the comments, leave us some notes, And we hope you join us every day at 1 o'clock for our live demonstration. And of course, while you're all safe social distancing at home, check out more science activities with us online at azscience.org. We'll see you guys next time with more Sari on Science. Bye!